All right, so we're going deep on Algebra 2 today.
Really getting into the nitty-gritty.
Exactly. And specifically, we're going to be focusing on functions and graphs.
Oh, that's a good one.
Yeah, and I see we're using Algebra 2, functions and graphs, as our source material. So,
Excellent choice.
yeah, we've got relations and functions, domain and range.
They've got function operations
Oh,
and
wow.
composition.
Don't forget transformations.
Oh, of course, transformations. How could we forget those?
It might seem a little bit abstract when you're first looking at it.
Yeah, but it's really the backbone
Yeah.
of so much.
Of higher level math.
Exactly, and it's everywhere.
Yeah. So let's get into it. So
Let's do it.
we've got relations and we've got functions.
Right.
Are they the same thing?
Whoa.
What's the difference and why are functions so important?
That's a great question. So, a relation, it's really just a set of ordered pairs.
Okay.
It's inputs and outputs. It connects things.
Okay.
You could almost think of it like a map connecting different cities. But a function, that's something special.
Okay.
That's where every starting point can only go to one destination.
Okay.
So it doesn't matter how many times you travel from point A, you will always end up at point B.
So it's predictable.
It is predictable. Exactly.
Okay. So that's what makes
It makes it so powerful.
so useful. Yeah. So if a relation is like just a map, a function is like a GPS.
Oh, I like that.
It takes you to the one spot.
Yeah, that's a great analogy.
And that's why it's so useful in computer programming, because one input's going to give you the same output
Exactly. You want that predictive.
every time.
Yeah, exactly.
All right, so let's move on to domain and range.
Okay.
So, we're thinking about functions like they're little machines.
Right.
What are the limits of these machines?
Well, so the domain is all of the acceptable inputs you can put into that machine.
Okay.
It's all the raw materials that it can take.
Okay.
And the range is all the possible outputs.
Okay.
It's the finished product that machine can create.
So it's not just about what the function does, but what it can and cannot handle.
Exactly.
I see.
Right.
So understanding the domain is really important because you don't want to put something into the function that's going to break it.
Right. You want to make sure you're using the right ingredients.
Right.
The recipe.
Yeah, like putting, a negative number.
Yes.
We need a positive number.
Exactly. Or trying to take the square root of a negative number.
Right.
You can't do that.
Yeah, you're going to get an error.
You'll get an error. Exactly.
Okay, so domain and range. Super important.
Very important.
We're getting those right answers.
Yes.
Now, things get really interesting when we start talking about function operations.
Yes.
And composition.
Yes. This is where we get to link those machines together
Okay.
and create more complex processes.
So we're not just using one function at a time. We can combine them.
Yes, we can combine them in
Our-
all sorts of ways.
It's like Lego blocks.
It is like Lego blocks. That's a great way to think about it.
Okay.
You can add them.
Yeah.
You can subtract them. You can multiply and divide them.
Okay.
You can even put functions inside of other functions.
All right.
That's called composition.
Right.
It's like a chain reaction
I see.
of functions working together.
So, for example, we always see the basic examples like with price and quantity.
Right.
But, like, what's a real-world example
Oh, well, let's think about,
of how this would really be applied?
how about finances?
Okay.
So let's say you're trying to calculate the growth of an investment.
Okay. Yeah, compound interest.
Exactly, compound interest.
Yeah.
So you could have one function that calculates the interest earned each year,
Okay.
and then you could have another function
Mhm.
that takes that interest and calculates the total value of your investment over time.
So they're working together.
They're working together, exactly.
That makes a lot of sense.
Yeah.
So that's function composition.
That's function composition
Like action.
in action.
Very cool.
Okay.
Okay. Last but certainly not least, we have transformations.
Oh, yes. Transformation.
So this is where we're taking that basic function
Right.
and we're shifting it, we're stretching it, we're flipping it
Exactly.
on the graph.
It's like manipulating a digital image,
Ooh.
but with equations.
Okay.
Yeah.
So we're not just understanding what the function is, but how we can manipulate it.
Exactly. You can customize it.
Right, to get what we need.
Yeah, to fit different situations.
Okay, so could we use transformations to
Yes.
predict how a stock might perform
You absolutely could.
based on past trends?
Yeah, you can use transformations to analyze and
Wow.
predict all sorts of things.
That's really cool.
Yeah.
So it's applicable in all sorts of fields.
Yeah, finance, physics, engineering.
Yeah, that's awesome.
It's everywhere.
Wow. So we really went deep on functions today.
We did.
It's amazing how these concepts that seem so abstract when you're learning them in Algebra 2
Yeah.
are really applicable in so many different areas of life.
It's all about relationships.
Yeah,
How things are connected.
it's really cool.
Yeah.
Well, thanks so much for joining me today
Oh, it's been a pleasure.
to go on this deep dive into functions.
I always love talking about functions.
And to our listeners out there, I hope this has you thinking about how you can use the idea of functions
Yeah.
to analyze a situation or solve a problem in your own life.
It's more relevant than you might think.
Thanks for listening.
See you next time.